All right, we're in Precalculus, lesson 4-5. Today's date is Monday, February 8th, 2021. Yeah, so as I was saying earlier, we're talking about why I lied to you in the last lesson. I know, Chewy, you're doing like COVID stuff, so when you're done, just put down your phone. It's okay to do.
I think I'm about to stop right now because they're asking about my health insurance and I don't have it stuff handy.
Okay. You don't have like your health insurance in your wallet?
Not on me. No,
Okay. All right, our objective today, one of the 4 people that are here in this classroom. That's so sad. Caroline, 5 people now. Woo. Yeah, the only addition that I made from our last objective is I'm telling you the truth now. All right, so let's talk about why I lied to you. I'll get to this first one in a sec. So let's go through example 1 again, and you should graphically be able to see that it doesn't work. Let's solve it like we did on Friday. So help me out. I'm trying to solve for x. You know how to do this. You did the homework, maybe. No one has turned it in yet, but maybe you did it. How do I solve for x? I need an undo sign on both sides. Caroline. Arc sine, write it down. We write arc sine of the left-hand side. We write arc sine of the right-hand side. And that undoes the signs. That's the whole point. Those are gone. Shwink, shwink. And I'm now left with x is equal to, and this is the hard part, principal value of arc sine of root 2 over 2. So you're thinking, okay, sine is y coordinate. Okay, so sine, is that right or is it up? Where's principal value for sine, right or up? Right, good. Okay, so somewhere over here, point to a height, a y coordinate of root 2 over 2. 1, yes, yes, yes. Emily and Chewy, where's root 2 over 2? Where's a y coordinate of root 2 over 2? Yes? It's that way. It's a 45-degree angle. 45-degree triangle will give you root 2 over 2. So we'll draw it over here in the notes. What does our unit circle look like? Why are we getting this answer? This unit circle is important to write down for your notes right now because we're going to be referring back to this. This is part of the key to why I lied to you. So here is our x-axis, our y-axis, and I have technology. You guys are going to have to do your best attempt at drawing a circle. But there's my circle. And we say, where do we have a y coordinate up here? A y coordinate of root 2 over 2. This is, actually, I should say it's right about, what is root 2 over 2? As a decimal, square root of 2 over 2. It's about 0.7, so I'll say right about there. This height right here is root 2 over 2. Where do we have that height? That height comes out here. Boom. And that's a 45-degree angle. And we say that this angle right there is, with the quiet raised hand, in radians. In radians, Ellery, pi over 4. Say that this angle is pi over 4. So we come over here and say that x is equal to pi over 4. But then again, if you rotate 360 degrees or 2 pi radians, you get back to the same answer. So we had to say, oh yeah, don't forget your plus 2 pi n. And we box it. Boom. So before I move on to the new stuff, for the old stuff, for this step that I just write here, what is your fist of 5? 4, 5, 4, 4, 3.5. Okay. Okay, but we have a general idea. All right, so I'm going to give you some thinking time. This is not the right answer. Let me prelude to why that's not the correct answer. If I go to Desmos, not the calculator. Oh yeah, calculator, not scientific. If I go here and I type in sine of x, I'm going to type in this equation. Oh, I'm not using the stylus, so my writing's off. I'm going to write this equation and this equation. I'm trying to find where those two equations intersect. They should intersect at pi over 4 because that's one of the answers if I plug in 0 for n. So let's do sine of x. By the way, I'm going to make my x-axis step by pi over 4. So it looks a little bit better. And then I'm going to type in square root of 2 over 2. Square root of 2. I just want to say divide by 2. I'll make that a function, y equals. Come on now, y equals. And I'm trying to find where are all of those solutions. And if I come over here. Maybe I should step by pi over 2. And let's just do minor grid lines turned off. If I zoom in here, I should be able to find that pi over 4 is a solution. And indeed, this spot right here, look at that x coordinate. The x coordinate is pi over 4. We're trying to find x answers. Well, this has the coordinates pi over 4 and then square root of 2 over 2. By the way, square root of 2 over 2, if you didn't know, is 0.707. It says so right up here. So that is an answer. Well, what was another answer? If I just write in our formula over here, our pi over 4 plus 2 pi n, and I get a drag a slider for n, I can make this step by whole units. If n is 0, it's this 0.785, which is exactly what we got right here. 0.785 is pi over 4. Again, you can check that with the calculator. Pi over 4 is 0.785. So check this number and this number. Yes, they're the same. 0.785, 0.785. If I step by 1 unit to the right, then I should be able to get 7.06. What is that? Well, I added 2 pi n, so this is really going to say 9 pi over 4. And 9 pi over 4 lives. Let me make this a little bit more I can't say this word. Illustrative. Let's go like this. Let's say, let's still add a slider for n. I'll make this step by units. But I'm going to say that this is the x coordinate. And the y coordinate will be square root of 2 over 2. So you can actually see this. You can actually see a point. And I'll label this answer. So you guys see this answer over here? I don't know how well you can see it. If I shift this over, do you see the problem? Let me scale this out too. So the y-axis is going to be between negative 1.1, negative 1.1, and 1.1. Our x-axis, let's make this like negative 10 to 10. Oh, double negative made it positive. Whenever I drag my n, because n is just an integer, it should represent every single intersection between our sine wave and root 2 over 2. Every single point that you touch both of those functions is an answer that we're trying to generate. That's the purpose of what Friday's lesson was supposed to be, of solving for x. It's all of the solutions that intersect. But notice, something is wrong. No matter how you drag this, something is wrong. Who can identify the problem? These are solutions. That's not it. Ellery, what's the problem? Oh, sorry, Oscar had his hands up too. Oscar will verify. Yeah, it's just going up by 360 degrees. Yeah, Oscar, how would you say it?
Well, you said one side's the answer, right? What about, wait, isn't the other side the answer as well?
Yeah, exactly. Like, look at this, guys. This is an answer, and my formula here generates that. Pi over 4 plus 2 pi n generates all of those answers, but Ellery and Oscar are both saying, what about that one? What about that one? What about that one? We're missing literally half of them. That's a problem. How do we generate that other half? And you guys actually know how to do this already. You might not know how to do it right now. And I'm just going to give you 5 minutes and let you struggle. And hopefully one of you or two of you or all of you will figure out what the process is. So you can either think about this graphically, or even better yet, think about it in terms of the unit circle. I'll give you a hint in about 2 minutes. So your hint is this. The question that this was originally asking before we took arc sine was this. Let me retype the question. What angle gives a y coordinate, I can't spell, coordinate of that square root of 2 divided by 2? That was the question that this equation was really asking. if you really think about that question just as the question without thinking of any specific rules that Mr. Sindel introduced on you guys, a restriction that I reduced on you, or I put on you guys, there should really be two answers. Because, well, obviously one of them would be the other half, but what would be the second answer? You know, one of the answers, there should be a second equation that pops out of this question. Again, I'll give you guys a few minutes to try this out on your own. I don't know. All right, so as a review of what most people have figured out is, if I don't restrict my domain in order to make it invertible and all that cool stuff from a few lessons ago, if I simply think of this as what angle gives a y-coordinate of root 2 over 2, well, the y-coordinate of root 2 over 2, if I zoom into my unit circle, happens again over here on the left-hand side. This y-coordinate really is a y line. This line intersects the circle here at pi over 4. I can label it over here as well. And over here at 3 pi over 4. All that means is, my 4 is all weird, is that I have two equations. One equation that uses pi over 4, and my second equation that uses 3 pi over 4. So here's my second equation. X is equal to 3 pi over 4 plus 2 pi n. And that is the final answer. And we'll box it. We have two equations that generate all of the answers. And how can we verify this? Let's verify it graphically. Check this out. So if I come back over here and I generate a new sequence, and I guess I should really have this so you can see it a little bit bigger. If I now have 3 pi over 4 instead of pi over 4, and I do again plus 2 pi n, comma, square root of 2 divided by 2. Check this out, and I'll label this another answer. Whenever I drag n, I'm now getting both of them. I hope that's proof enough that we have all the answers. No matter where I drag n, this will intersect the function everywhere. You now have the complete story, the correct answer, not the incorrect answer, of all the solutions. And I'll also summarize that already up here. When I come up here, all solutions, instead of just doing the principal value here, this used to be principal value, it now says both inverse solutions, and I have a little asterisk on both, plus again that period times integer, which I think is even easier than you were doing before, because now you don't have to think about principal value. You don't have to think about the correct domain. If you say down here that this point is 7 pi over 4 instead of negative pi over 4, I don't care. The point of me teaching you principal value is for you to understand what the calculator is doing. Whenever you punch into your calculator and you say, what is arc cosine of root 2 over 2? You now know what the calculator is going to say. The calculator will always give you the principal value. You, however, know it's just right there on the unit circle. That could be 7 pi over 4, or it could just be negative pi over 4. They're the same answer. So you guys get to choose whatever is easier from here on out. If you want to do the principal value and do negative pi over 4, that's fine. If you want to do 7 pi over 4 and go all the way around, that's also fine. Both of them are the same answer in my book. So why did I put a little asterisk here? Sometimes it's only one solution. Why? Because check this out. What if, on my graph, what if I move this up to 1? Then there's not two sides of my sine wave or my cosine wave. There's only one spot here. So you have to be careful. Sometimes you'll only have one point. And that's when you have like, what is arc cosine of -1? There's only one coordinate, one x coordinate of -1. It's all the way out here. I can't choose two different points. So just be careful. Sometimes you'll only have one. It means you have less work to do, which means you can give yourself a high five or something. Less work. Awesome. All right. So here are some examples. Your homework tonight is to just finish these examples. Can you finish these examples doing both solutions? You already have half of them because we did these exact examples in the last lesson, but now you know the complete story. Ellery?
I have a question about
Yes. All right. I'll be going through these after you attempt them, but I want everyone to attempt all of these 4 examples. And then if you do that, you have no homework. Y divided by X. Yeah. Oh yeah. Those are going to get really tricky really fast. Yeah. Example 4, that's a tricky one. All right. Well, we ran out of time in class. I don't want to show a video solution of these yet. If you're watching the video, you can go check online on the website. This is just in your notes. Again, this is homework. You need to be doing this. Example 3 got squished in there. I'm going to change the formatting of this so there's more room next year. And yeah, example 4 is your last one. And that is your homework. Make sure that is done. I will see you guys later.